Okay, so it's 10 o'clock now, and we're talking about 4D space, four-dimensional space, where we previously had 3D space, where we had spheres, cylinders, then stuff like that. With 4D space, what we're able to do is jam a fourth axis that is able to discretely or continuously measure time. Okay. So one way we can do this is by taking a look at a function of a function of a function and see just exactly how these functions coincide with each other. On a 4D space, what happens is that not everything happens at the same time, but there's an instance that shows a graph that shows that everything is happening at the same time. The point is that 4D is allowing us to simulate a model and different intervals, with also being able to flex on some of the fourth axis, which is the t-axis model, and flex what essentially would no longer be a normal linear scale, space-time scale. So I mean, it's very much looking at one number. For instance, if we have an output at, let's say, 1/10 plus 1/11, that would give us 0.10 Okay, so we have a continuous infinite number that is being outputted at f of x, some f of x function equals 1/10 plus 1/11. So we have a basic output here, a coordinal pair, and the idea is that when we match this pair at 0.1011, we so we're at 10:03 right now. So what I can say is that if we were to output this at point 3, so let's say the third tick mark on the time axis. So if we could jump scale to meet our goal at 10:11, so then we would be at 3, 4, 5, 6, 7, 8, 9, 10, 11 here. So we have the 11th tick mark measurement is going to be where we see that it's landing on a square pattern. So what happens is, if you had a, let's say, a 3D space, and you saw a cube, and within this cube you see that there might be like a straight line, but there's one little point that is just a corner point. It's just one little crack, one little corner that says that this changes everything. So it's an inflection point. And so that little crack in the cube is going to be our 1011. And so what we want to do is we want to actually handily, readily close that hole in the wall. Because it's causing all kinds of crack. And we go from this cube to what might be a cylinder, or just a straight line function, or it just might be a chaotic function math set. So what the idea is that we're no longer able to simulate the game or the model on the t-axis when this open point here is not getting closed. So for whatever reason, we had an imperfect cube, and what we need to do is we need to close that joint and be able to run the game. So we do that by coordinating the X and Y axis. What I normally do with this number, with this is test on a linear axis. So it's on a 1D scale. So on a 1D scale, on a scale of 1 to 10, what do you feel about Friends? Is it a 10 or 11? Because that's kind of the thing. It's really just a 10 or a 1. So that's how it falls into a heat map. So you see that you can parse functions in the previous video. Parsing functions for the 1011, you're just basically able to go to, you're out of 10, and then you drop to a 1. So what half or an 11, and it just depends on how you want to parse the function, how many decimal places, and just exactly how you want to integrate the parse function. And so it's CD, but it's the point is that you're not doing that here. What you're doing is you're getting an output. So you want to get this figure, because you have this point that needs to be closed, and in order to continue with the rest of the math function. And so you do this by solving. So you can solve. So let's just say, because I don't know exactly what what it might be other than x to the third, f of x to the third. So at this rate, what we can do is say, okay, so f of x to the third equals 1/10 over plus 1/11. And so that makes us a little bit queasy, because now we got to do some hard computation there. So let's just say 0.10 to the 1/3. That gives us 0.45, which I don't know exactly what that signifies. But we're going to do 0.11. Actually, it's going to be 0.10111 to the 1/3 power. So that just gives us 1/3. It just gives us 1/3. So we close the gap there at about 1/3, and it goes to 0.10. So that's how we're able to meet that point. So we know the x pair, the xy pair, and so now we can resimulate the model, and it's going to be able to go on the 4D axis again.